All right, so like any problem of this nature, we're going to have some constraints that we need to abide by. For this particular problem, we're going to use X1 to represent sweatshirts with front print, X2 to represent sweatshirts with back and front print, X3 to represent t-shirts with front printing, and X4 to represent t-shirts with back and front printing. So our objective function, in order to maximize Z, which is our profit, we have to multiply each X by the amount of profit that it will make, and then we add up all of those. The X's are what's going to be maximized in the solver results, which will be next slide. But as for constraints, we only have 72 hours to produce all of these shirts, so all of the time that will be spent making each sweatshirt and t-shirt that has to add up to be less than or equal to 72. We have a maximum of 1,200 boxes that these shirts and t-shirts can fit in, so you'll see that just under the time constraint. As for a budget, we have a maximum of $25,000, so the cost per shirt and everything has to add up and multiply to be under that number. We only have a maximum of 500 sweatshirts and 500 t-shirts in stock, so we cannot use more than 500 of each one. Now moving on to the solver results. On the left here, you can see this is our product mix that we have in this Excel document. On the bottom right, you can see all these constraints that are laid out. Down on the bottom left, you can see X1, X2, X3, X4. That is what is maximized in solver. In profit, that is equal to all of those maximized quantities multiplied by their respective profit per box numbers and then added all together. So all in all, it will equal $45,522. As you can see on the right side with the solver parameters, we have set objective is cell B18. That's the profit that we're set to maximize by changing variable cells. B14 through B17, that's X1, X2, X3, X4, like I just explained. Our constraints, we have all the formulas in there that I just explained. And yeah, that's pretty much it for this. On to a summary of the optimal solution. Our optimal decision variable values ended up being X1 is equal to 175.56, X2 is equal to 57.78, X3 is equal to 500, and X4 is equal to 0. So with that, our maximized objective function is 990x1 plus 125x2 plus 45x3 plus 65x4. We plug all those numbers in, and that will equal our maximized profit of $45,522.22.
And with that all said, when you put in the constraints of a dozen shirts or sweatshirts in a box with a 1,200 box capacity within 72 hours of it being delivered and have $25,000 for production run, you get your answer of 175.56 for sweatshirts only with the front printing, and the second answer of 57.78 for sweatshirts with the back and front printing, 500 for t-shirts only with front printing, and 0 for t-shirts for back and front printing, giving you a total profit of $45,522.22. To answer our first question of the what-if analysis, scenario 1, what we did was we increased the profit per dozen and changed it to, for the front sweatshirt, the front print would be $85 now instead of $80. For the back and front of a sweatshirt, instead of $115, it's $120. For the front of a t-shirt, it's now $40 instead of $35, and for the front and back of a t-shirt, it's $80 instead of $75. This then changes the model to maximize profit of 85x1 plus 120x2 plus 40x3 plus 80x4, which is then subject to the same constraints as before, so those formulas still don't change. To continue on from the scenario 1, the optimal solution would be when you after you put in the constraints and the new numbers would be the front sweatshirts would then be 339.6226. The sweatshirt's back and front print and also the front shirt print would both equal 0, and the shirt's forward and backward print would be 181.1321. With that said, the company will then produce t-shirts back and front printing, and the company will produce sweatshirts front printing but leave X2 and X3 out because no money is made, giving a total profit of 43,358.49, concluding that if you increase the profit per dozen, you would decrease the amount of total profit you make.